Hey everyone! In this video, I'll show you how to unpack, pack, and repack texture channels, rearranging them right inside the Unreal Engine editor. And towards the end, I'll demonstrate how to create optimized normal map versions that can save you up to 50% of GPU memory. For this, we'll be using the Pro Texture Tools plugin. You'll find the link to the plugin in the video description. Using this plugin is extremely simple, and you'll see for yourself in just a moment. Right now, I have a static mesh with textures that I imported from Unity. Unity uses Smoothness instead of Roughness, which is stored in the alpha channel. The red channel contains metallic, green has ambient occlusion, and the blue channel in this texture is empty. First of all, I don't need the alpha channel. Textures with alpha channels take up twice as much memory, so I need to free it up. Second, I need to get roughness instead of smoothness, which means I need to invert the alpha channel. As you can imagine, doing these conversion procedures manually is very time-consuming and inconvenient. Let's see how we can quickly repack texture channels using Pro Texture Tools. Select the texture in the content browser, right-click to open the menu, and you'll see the Pro Texture Tools submenu under Texture Actions. Choose Repack Texture. A channel repacking dialog window opens. Here, we can either set channel values manually or select a ready-made template, and we can also create our own. To save time, let's select a ready-made template. There we go. The repacking values are set automatically. We can see that the alpha channel will be inverted and placed into the red channel of the new texture, and values for the other channels are also set. I'll leave the file name unchanged and click Repack. Done. Let's look at the result. Now in the red channel, we have roughness instead of smoothness. In the green channel, we have metallic. In the blue channel, we have ambient occlusion, and our alpha channel is empty. It's not being used. And if we compare the two textures and look at the resource size value, we'll see that the repacked texture takes up half the memory. This is all because we got rid of the unnecessary alpha channel. Now, let's create our own template and process several files at once. Let's say I want to create a template that inverts all channels. Why not? So, I select Invert for each channel. Click Save Template. Need to choose a name for the data asset. I'll call it Invert Repack Template, and it can be saved anywhere. We see a message that the template was successfully saved. Now, let's try selecting multiple files and processing them using our new template. I'll select several files, open the Repack Texture tool, select the new template we created, then we can either overwrite the current files or create copies with a suffix. I'll create copies, click Repack, and we're done. We've created our own template and processed multiple files in a second. Moving on, texture unpacking. This is as simple as it gets. Select our texture, go to Pro Texture Tools, and choose Unpack Textures. A dialog window opens where we can select which channels to extract, change the suffix for each channel, and optionally invert a channel during extraction. Click Unpack, and we get separate textures for each selected channel. As you can see, it's incredibly straightforward. Now, let's pack everything back together. Select the textures we want to use for packing, go to Pro Texture Tools, and choose Pack Textures. A dialog window opens, and here we have complete control over how the texture will be assembled. For each channel, we can select the source texture and which channel from the source texture we want to use. We can also just fill a channel with black or white, or invert a channel. Let's set the values and assemble the texture. Done. Everything is very easy and fast. Next, let's talk about the Resize Textures tool. Unreal Engine has a similar tool, so let me first show you what Unreal Engine offers, and then we'll see how Pro Texture Tools differs. So we select a texture, choose the Texture Source Actions submenu, and see Reduce Size there. This window opens with a list of selected textures, and here we can change the texture size threshold parameter to reduce all textures from the list that are below this value. That's basically it. Now let's look at the equivalent tool in Pro Texture Tools. Open Resize Textures. Here we have a bit more capability. We can not only reduce selected textures, but also process all textures from a selected folder or scan the entire project. I usually work with folders. After new asset folders are added to the project, I scan these entire folders, and if there are textures that are too large, usually if textures are larger than 4K, I reduce them immediately. Let me, for example, open the MetaHumans folder, and you can see that there are 8K textures in the folder. That's too high a resolution. And then I have the option to either overwrite the current textures or create reduced copies. I'll choose to overwrite, since I definitely don't need textures with such high resolution. And here in the bottom right corner, I can see the estimated amount of disk space that will be freed after processing. I see that 1 GB will be freed, which is very good. Next, let's look at the Cleanup Unused Textures tool. This tool can help you discover textures and assets that aren't used anywhere in the project. But I want to warn you right away that it should be used with caution. Never delete files immediately. Use the option to move them to the Unused folder. Using Cleanup Unused Textures, we can not only find textures that don't have hard references, but also find textures that do have references, are used in materials and assets, but none of the levels inside the project use these textures or assets associated with them. We can find such textures by scanning the entire chain of materials and assets connected to them. But there are certain limitations. Textures and their associated assets can be loaded into a level using soft references, or can be used, for example, in UI widgets, and then they're not physically present in levels. So I'll repeat again, be careful. Use this tool only if you know exactly what you're doing, and never delete files immediately. Let's see how this works. Let's scan this folder with our textures from Unity and see what's there. So we see a list of textures. Some textures are marked in red and their references value is 0. This means there are no materials or assets in the project that have a hard reference connection with these textures. Some textures are marked in yellow and their references are greater than 0. This means there are assets in the project that use these textures, and the references value is the number of these assets. If I duplicate the material and scan the folder again, you'll see that the references value increases. Next, what is used in levels? We see that for all textures, this parameter is marked as not used. This means there's not a single level in the project where these textures are directly used. Let's add an asset to the level that we know for sure uses our textures from this folder and see what changes. As you can see, now the Used in Levels value displays the name of the level where these textures are present. This way, we can scan folders and find textures that could potentially be unnecessary in the project. So we've scanned the folder, we have a list of textures displayed, and then we can apply various filters. Display only textures without hard references, display only textures that aren't used in levels, or display both simultaneously. Now, let's select all textures from the folder that aren't used in levels and don't have hard references, and move them to a separate unused folder. In the bottom right corner, there's an Include Related drop-down menu. With the None value, we'll only move textures to the folder, but we can also choose to move materials related to the textures, materials and meshes, or all related assets. I'll choose All Related Assets. I click Move Selected. Go to the Unused folder, and here are all our textures and all assets associated with them. And now we can decide whether to delete all this or if we still need some assets in the project. So, with careful use, this tool can prove to be very useful. And the last tool I'll talk about is Create Optimized Normal Map. The thing is, if we look at any normal map, we'll see that only 2 channels are used, red and green. The blue channel isn't available. And if we change compression settings from normal map to default, we'll see that the resource size decreased by half. So if we can use normal maps with the default compression method, we'll not only reduce memory consumption by 50%, we'll also get an additional free blue channel where we can place, say, roughness. And this way, for some assets that don't use metallic, for example, we can use just 2 textures, albedo, and an optimized normal map with roughness in the blue channel. And this normal map will also take up half the memory. If you use this approach on a project-wide scale, you can achieve huge memory savings. So Create Optimized Normal Map does exactly this. It creates an optimized version of the normal map and allows you to fill the blue channel from an additional texture. But that's not all. For the normal map to work correctly, we need to independently calculate the value for the z-coordinate using data from the red and green channels. Create Optimized Normal Map will help us automatically create a ready-made material where the z-coordinate value is already calculated. And you can use this material as a starting point for creating your shaders using the Optimized Normal Map. Let's look at an example of how this works. In this folder, I have a brick wall normal map. And I made a simple material where this normal map is used. For the albedo, I'm just using a gray color, and a separate texture is used for roughness. We'll use this material for comparison with the optimized version. So we need to select the normal map and the roughness texture. Then invoke Create Optimized Normal Map. A dialog window opens. Source texture is our additional texture from which we'll take data for the blue channel. Next, source channel. Here we select which specific channel we want to transfer data from. Then, blue channel usage. This parameter is used when automatically creating the material. That is, we can choose where the blue channel will be connected. I'll leave the file name unchanged, and there's the Create Test Material with Z-Channel Reconstruction checkbox, which is responsible for automatic material creation. I click Create. Excellent! We got an optimized version of the normal map with roughness data in the blue channel. Now, let's open the automatically created material. As you can see, all the nodes for calculating the Z value are already set up, and the blue channel is connected to roughness. Now let's compare the two materials, with the regular normal map and the optimized one. I don't know about you, but I don't see any difference between the two materials. On the left is the original normal map. On the right is our optimized one. But now, let's compare these two materials by memory usage. As you can see, the difference is very significant. That's it. As you can see, Pro Texture tools can be extremely useful, and using these tools is very simple. Thanks for watching. If you have suggestions or requests for expanding the functionality of this plugin, write your ideas in the video comments, and I'll try to include them in the next version of the plugin. Thank you all for your attention. See you next time.